f of x is going to change signs anywhere you have an x-intercept. Or in other words, it'll go from being on one side of the x-axis to the other side, right? When you have a 0, that's where it's touching the x-axis, usually going to the other side of it, right? Like crossing across it or something like that. So it says they want us to sketch the graph below. Quick reminder for us, we know that the parent function x cubed looks something like this, right? Okay, what if I asked you what negative x cubed looked like? What would you tell me? Right, it just flips it. So now this end would be the end that's up, and then it goes down like this, right? Okay, so keeping that information in mind, we are asked to sketch the following graphs. Okay, so today, instead of writing your polynomial as maybe some term that's like 4x to the fourth plus 3x to the third minus 2x squared plus 1 or something like that, they have it in factored form. They did that as a favor to us because remember, if you have a factor, if you want to know what your 0 is, you just take your factor, set it equal to 0, and solve, right? So for example, if I wanted to know where this is going to give me an x-intercept, I take that first parenthesis, I set it equal to 0, and I solve. When I solve, what am I going to get? 4. So this is going to let me know that I am going to have a 0 at 4, or a root is what they called it yesterday, at 4. Okay, so on this coordinate plane here, 1, 2, 3, 4, I'm going to have a 0 there. Okay, what would this next parenthesis, this x minus 1, where am I going to have a root at for that one? At positive 1. Okay, and what about that last one that's x plus 2? Where does that tell us we have a root? Negative 2. All right, so now I have my roots. Okay, we are only talking about cubic functions today, but just a reminder that even though this doesn't have a cube in it, this is 3 things being multiplied together, right? Well, I've got 1x here, 1x here, and 1x here, right? What's x times x times x? X cubed. So if I were to multiply this back together, I know it's going to look something like this, right? Now, it may have some more terms in it, right, because it's got some extra factors in there, but I know that this end should point up and this end should point down, right? Okay, so I'm going to start drawing my graph, okay, and I am going to, like it says here, change signs. Well, up until this point, all my values were positive, right? They're above the x-axis. But at the 0, that's where it changes sign. So it goes below, okay? But it has to cross through this next 0, so now it's going to have to go back up, right? So it changes signs again at that 0, okay? And it's going to come all the way over here. Got to go back through that 0 and change signs again. So it does turn out that this end ends up pointing down, just like we said it would, right? Okay. All right, let's do another one. For example number 2, according to this first parenthesis, where am I going to have a 0? 4, okay. So 1, 2, 3, 4. Okay, according to this parenthesis, where am I going to have a 0? 1. And according to this last one, -2, okay. All right, and again, if I were to multiply these x's together, I would have x times x times x, which would give me x cubed, right? But what do you guys see out front here? A negative. So what does that negative tell us about our graph? Flips it. So now the left end should point up and the right end should point down, right? Okay, so this time I'm pointing down. I get to this spot and I go changing signs. Then I change signs again. And I change signs again. All right. Okay, let's do that again. Let's look at number 3. On number 3, where am I going to have zeros? All right, -1 and +2. Okay. All right, now this one is understood to just have the 1x in it, right? But this quantity is squared. So that's an x squared there, right? Okay, so what's x squared times x? X cubed. Okay, so still x cubed. There's no negative out in front of this one, right? So we don't have to worry about that. So that means the right end should point up and the left end should point down. All right, so I start by pointing up. Okay, and I'm going to come through here. And then I'm going to start coming back up this way. But if I go through, it's not going to point the right direction, right? Okay, but right here, that one was the same thing twice, right? That is what we call a double root. And when you have a double root, instead of crossing through like normal, you bounce off the x-axis. Okay, so anytime you have a double root, you are going to bounce off the x-axis. Meaning, instead of going through, it turns around and sends you right back the direction you came from. Okay, so for any of these that we've seen so far, when there's just an understood exponent of 1, right? All of these that we saw before just had an exponent of 1, okay? So if your exponent is 1, this just means you cross through the x-axis, right? Like normal. But if you have a square, or really any even exponent, 2, 4, like if we had one of our quartics, you have a bounce, okay? So even number, you bounce. Okay, let's do one more. Number 4, where are we going to have a root at? 4. So 1, 2, 3, 4. Okay, and this function is cubed, right? So that does mean I have x cubed. But in front, I have a negative, right? So that means my ends are going to change directions. So now this end points down, and this end points up. Okay, so we know what the cubic function looks like, right? It comes like this, and then it kind of does something like this on the x-axis, and then it starts to go back up, right? This little curve within it, right? Okay, so anytime you have an exponent of 3 or any other odd number besides 1, so 3, 5, 7, and so on, okay, you're going to have that little curve that we see right here. Sometimes we call that like a little wiggle along the x-axis, okay? So we can have 3 things happen, right? If it has an exponent of 1, we just cross through like normal. If it has an even exponent, like 2, then you bounce off the x-axis. And if it has an exponent like 3, 5, 7, so on, we have that little curve or that wiggle on the x-axis, okay? All right, so keeping that in mind, now instead of us drawing it, they're going to give us the picture and we're going to be able to deduce all the other information. Okay, so first thing they ask is where do we see roots? Remember, roots are x-intercepts, right? So in this picture, looks like we've got one here and one here. Okay, so this is 1, 2, 3, 4. So it looks like we must have them at where? Okay, -2 and -3. And then also, looks like we got another one over here on this side, right? And if we count that direction from our x-axis, we have one at 5. Very good. All right, so we're going to list our roots as being at -3, -2, and 5. So then they ask us, how would you then write those as factors? Well, when we put them in the factors, it's always the opposite sign, right? So the factor for -3 would actually be, right. And the factor for -2 would be, right. And the factor for 5, x minus 5. Nice. So then they ask for the equation, and in this particular case, they say, what would the equation be in factored form? Well, that's easy enough. Our function would just be x plus 3 times x plus 2 times x minus 5, right? Perfect. Okay. All right, flip it over on the back. Let's look at another picture, see if we can come up with the equation. Oop, forgot to erase from earlier. All right, so for number 6, it says we're going to find the equation if it passes through this coordinate point. Okay, so we're going to start out the same way as last time. We need to figure out where exactly we have roots. Looks like we got 3 of them, right? So where do we have roots this time? Okay. -4, -3, and 1. Perfect. Okay, so how would I write those factors? Very good. Okay, and they do ask for the equation in factored form. Okay, so it is going to have these 3 factors in it, but we also need to keep in mind that they said it goes through this point in particular, right? Okay, so remember this is a coordinate point, some x and some y value. So in an equation, what this might be telling us is maybe it has some sort of a stretch, right, that makes it go through that particular value. So we're basically looking for an a value, right? The a is what goes at the front of the equation, that number. Okay, so in factored form, it should look like f of x equals a times all of our factors. X plus 4 times x plus 3 times x minus 1. Okay? Our job is to figure out what a is. So in order to do that, we need to plug in what we now know x to be and what we know y to be. So remember, f of x is the same thing as y, right? So I'm going to plug in a 12 there. So I'll have 12 equals a times, I'm going to replace all of my x's with this -1. So I'll have -1 plus 4 times -1 plus 3 times -1 minus 1. And now we're just going to simplify and solve for a. So in that first parenthesis, -1 plus 4 is going to give us 3. And -1 plus 3. And -1 minus 1. Right. Okay, and then I'm just going to multiply those terms together. What's 3 times 2 times -2? -12. So -12 times a, right? Okay, and then how would I get a by itself? Right. So we end up getting that the a value is -1, right? Okay, so they ask for the equation in factored form. We now know our a value is -1. You don't have to put the 1. You could just put the negative, followed by all of our factors. All right. Okay, let's do another one together. Number 7, this one asks where we have roots. So for this one, looks like we got a root here and here, right? Where are those located? Okay, so we got one at 4 and one at 1. Okay, at 4, or sorry, -4. At -4, what do you guys see happened on the graph? It bounces off. So what does that tell us about -4? Right. Yeah. This one is one of those double roots that we talked about, which means it should have a square. Perfect. Okay. So then when I write out my factors, I'll have x minus 1 and I'll have x plus 4. But on that x plus 4, I'm going to put a square, right? Because there's 2 of them. Perfect. Okay. So when they ask for it this time, they say they don't want factored form. They want polynomial form. Well, factored form is easy enough because that literally would just mean writing down our factors like this, right? Okay, but they want polynomial form, which is like the expanded form, like with everything multiplied together. So we're going to have to multiply this out. Okay, so remember, squaring something means to multiply it times itself, right? So this would actually mean x plus 4 times x plus 4 right here, right? Okay. So let's do that first. So x times x is going to give us, right, x times 4, right? And then 4 times x is another 4x, right? So 4x and 4x, I can combine those. That's going to give me, right? And then 4 times 4, right? Okay. Okay, so we multiplied those together. Now we still have to multiply that by the other factor, the x minus 1, right? Okay, so what's x times x squared? X cubed. What's x times 8x? 8x squared. And x times 16. Right. Okay? Now I'm going to multiply everything by -1. -1 times x squared. -1 times 8x. Good. And -1 times 16. Right. All right, and then do you guys see some like terms we could combine here? Yeah. So our equation is going to end up being what? Mm-hmm. So those are like terms, right? Uh-huh. Combines with? Uh-huh. Nice. There we go. All right. Okay. And then we got one more. Says, find the equation for the following if it passes through the point 180. Okay. So we're going to have to consider that when we go and write the equation. But first, let's just talk about where our roots are. So where do you guys see us having roots in this equation? Good. All right, so that would make our factors what? All right. Nice. Okay. And then they ask this time that for the equation in polynomial form, and it has to go through a point like this, right? So that first means we need to figure out what the a value is. So let's start there. So remember, to find the a value, all I'm going to do is I'm going to go plug in for all my x's and for my y. So in this particular problem, what am I plugging in for y? 80. And what are we plugging in for all the x's? 1. So we'll have 1 plus 3, 1 minus 2, and 1 minus 6, right? Okay, and what is 1 plus 3? And 1 minus 2, right? And 1 minus 6, right? So what is 4 times negative 1 times negative 5? Good. So we'll have 20a. So what's my a value? Here we go. All right. So for our function, we're going to have f of x is equal to that a value, which we found to be 4, and then all of our factors. X plus 3 times x minus 2 times x minus 6. But they said they don't want the factored form. They want polynomial form. So that means we got to multiply it all out, right? Okay, so let's start with our first two factors. I could go ahead and also distribute that 4. So if I want to, I could go ahead and change this first factor to 4x plus 12 if you want to. So you're not doing that as a separate step. Okay, so we've got our 4x plus 12, and we're going to multiply that second factor by 4x plus 12. Okay, so I'm going to have 4x times x, which would be, right, and then 4x times negative 2. What would that give us? Negative 8x. All right, now we're going to do the 12. 12 times x and 12 times negative 2. Okay, well, that negative 8x and positive 12x, we can actually combine those, right? What would that give us? So I'm actually going to go ahead and just change that to a 4x in there. So plus 4x minus 24. All right. And then we still have that factor of x minus 6 that we got to multiply by, right? Okay. So 4x squared times x would give us 4x cubed. 4x squared times negative 6. Good. All right, now we'll do the 4x. 4x times x. And 4x times negative 6. And then we got to do the 24. So negative 24 times x. And then negative 24 times negative 6. Right. I kind of ran out of space here. So plus 144. Okay. Then the last step would be to go back and combine any like terms, all right? All right, so our biggest exponent is the cube. So we'll start there. We got 4x cubed. All right, so done with that. And then I've got a negative 24x squared and a positive 4x squared, which would leave us with, okay. All right, and then we've got a negative 24x and another negative 24x. So negative 24 and negative 24 would be negative 48x. And then finally we have that 144.